Okay, good afternoon class. So today we're looking at Euclidean geometry. Okay, we're going to now look at non-numerical examples, okay? The non-numerical examples is on page, the exercise is examples for exercise 9.7, is that correct? And 9.7 is on page 317. 17. 317. And exercise 9.6 was on page 300. Oh, there was an old summary. Oh, okay, makes sense now. I'm wondering. 17 pages, so the summary was fairly bulky. Did you guys read through the summary? Okay, you guys read through it so that to ensure that you got all the facts. Okay, if you don't, if there's something that you have forgotten, just write it down. Don't now summarize everything, because since we are applying the theorems, it should stick in your head. Okay. So this is the non-numerical examples is examples or riders that has no value to it. Okay, we don't know the exact value of the angles. Okay, so numerical is a number. So non-numerical is no number. So we work today. We're going to look at riders or sums here that has no value for the angle, as we had before. Okay, so it's going to basically be unknown angles here. And this non-numerical example, this is an example on page 300 and the exercise is on page 319. Okay. Right, so let's do the first one. Are you finding the geometry hectic? If you feel that it's hectic at this point, if I'm you, I would start again from the beginning, from exercise 9.1 and doing all the odd numbers and working your way all the way to where you are now. Okay, when you're done with that, you go back, you do all the even numbers and you work your way back to it. Okay. That's the only way you're going to master this, okay? You're not going to master it by seeing somebody else do it. You would have to do it on your own, okay? This will only be like a guide to you. But anyway, here we go. Nobody said it was going to be easy, but many people did it before and succeeded, okay? We got A's in geometry and so on, okay? Not A for absent. People, here we go. No? First question. We are told that PR is the diameter of the circle. People, if PR is the diameter, what do we know? We know that T2 is 90 degrees. Why? Angle in semicircle. And angle Q is 90. Why? Angle in semicircle. Okay. Then we are told that chord PT produces its own length. PT produces its own length, so it's extended its own length to S. Secant or secant? What is the secant or secant? Secant. Or secant, no? Second, SRQ. SRQ. What makes a secant? Cuts a circle twice. Okay. But cuts it once, what is it? Tangent. You guys understand? Okay. Secant. Okay, it produces its own length to S. Secant SRQ cuts a circle at R and at Q. TR and PR are drawn. First question. Prove that RST, this triangle here, is congruent to triangle or PT. People, there are 4 ways to prove congruency. What are the 4 ways? Side, side, side. Side, angle, side. Angle, angle, side. Right and hypotenuse side. 4 ways. No? So, in congruency, what can we say here? T2 is equal to T1 is equal to 90. Angle in the straight line. No? What else can we say? TR is common. Can you see that, people? What else can we say? ST is equal to PT. What type of congruency with that? What case of congruency? Side. Angle side. Why not RHS? We're using 90 degrees. There's no hypotenuse. You guys understand? Right. So let's write that neatly down. Okay. So where do we start? We say in triangle RST and triangle RPT. What can I say? I say that TR is your common side. Okay. Secondly, what did we say? ST is equal to TP. Why? Is given equal. Last one, we say that T2 is equal to 90 degrees. Why? Why is that 90? Angle in semicircle. Okay. Then we say T1 is 90. Why? Angles on a angle on straight line. And therefore T1 is equal to T2, which is equal to 90. So there we go. Whoops. Okay, so therefore triangle RST is congruent to triangle RPT. Just make sure that the order is correct. So it's RST or TP. Yes. And we said it's going to be side angles. So what does that mean to say? That means to say that the angle R in this triangle here is equal to angle R in that triangle. It also means that angle S in that triangle is equal to angle P in this triangle. Can you see that, people? And angle T of that triangle is equal to angle P. But that we knew already at this point. What else does that tell us? It also tells us that RS is equal to PR. So RS is equal to PR. It also tells us that ST is equal to TP. But that we knew already. And we also now know that RT is equal to, that we also knew already. You guys understand? That is why order is important. At this point, you won't be penalized for order. You write the wrong order. But it helps having the right order for the sums to come. Does it make sense? Okay. So just in our mind's eye, at the back of our head, we know that these two triangles are congruent. Okay, just take this off here. Right. You all okay if I take this off? Okay. So I need to keep the diagram in focus. Okay. Now B. In question B we are told if P1 is X. So what I do is I put the P1 there. Okay. If P1 is X, write the following in terms of X. So your angle S must have an X in it. Okay. So angle S is equal to what? X. Why? Why is angle S equal to X? Okay. Why is angle S equal to X? Huh? They're common. Congruent. The two triangles are congruent. Okay. Thank you. Equal to X. Why? Because a triangle STR is congruent to triangle PTR. Okay. What's the reason they gave in the textbook? Same. From congruent triangles. Okay, does this say from congruent triangles? It's the same as what I'm saying. Not so? Right, so that's number 1. Number 2. It says R3. I'm going to calculate R3. Exterior angle of a triangle. You all agree with that? Nice. Well spotted. So I was going to go along with it now. Can you see that, people? So R3 is equal to x plus x. Nice, well done. So R3 is equal to 2x. R3 is equal to 2x. Why? Exterior angle of triangle. Dot dot dot. And this triangle is PR. You don't have to name the triangle. Okay? That is 2x. And then the last question says calculate P2. But P2 is within this triangle here, not so. And I already highlighted that Q is going to be 90 degrees. Can you see that? Angle Q is 90. So we now say, firstly, that angle Q is equal to 90 degrees. Why? Angle in semicircle. So you say P2 plus 90 plus 2x is equal to 180. Why? Sum of triangles in this triangle PQR. So angle P2 is equal to 180 minus 90 is 90 minus 2x. Okay. Nice, no? Shaking your head in the wrong direction. Okay. You must tell yourself, oh, I love geometry. Every morning you tell yourself the same line. I love geometry. There will come a time that you're going to start believing your lies. What? Yes? By this 2 here? Which number? Number 3. The third one, yes? So you want to divide this by 2. This by 2. But remember, this is an equation. So what you do on one side, you must do on the other side. Okay, so there is no 2 here. If there was a 2 here, yes, then I would divide both sides by 2. But there is no 2 there. I don't need to divide. Anything else? Okay, we'll do another one. And example 2 is on page 318. Example 2 is on page 318. Here we are told that TR is a tangent to the circle. TR, oops, you actually need the top part. Make it a bit smaller, sorry about this now. So we are told that TR is a tangent to the circle at R. People, if TR is a tangent at R, what do we know? We know many things, no? We that generation of kids, no? We know? R4 equal to M2. What else do we know? R2 is equal to angle P. Why? Tango theorem. Okay. The ammeter PM. If PM is the ammeter, what do we know? R3 is 90 degrees. Okay. The ammeter PR is produced. What does produce means? Extended. PM is produced, extended to meet tangent, which is this here, at T. which is that point. Can you see that? TS is perpendicular. So that's 90. This is 90. So what does that mean? That TMRS is what? Cyclic chord. Why? Exterior angle equal to the interior opposite. Easy. No? I know you guys are getting upset because the sums are so easy. TS is perpendicular to PT and PR meets TS at S. MR is drawn. First question, we have proved that even without reading it, TMR is the cyclic quadrilateral. Imagine. Okay, so when we start, we start off by saying R3 is equal to 90 degrees. Why? Angle in semicircle. Now we're going to state the obvious, not so? So what do we say? Since. Yes, since what? R3 is equal to STP or PTS. STP, sorry, which is equal to 90. Because that angle is equal to that angle. Therefore, yes, carry on. TMRS is a cyclic chord. Why? Exterior angle equal the interior opposite. Okay. Or you heard somebody saying exterior converse of exterior angle of cyclic chord equals to interior. Also acceptable. Do you guys understand? Alright. Let's go to B. So this here for now. The B part of the question. Prove that R1 is equal to angle S. R1, there's R1, there's angle S. So how do I start? I say let angle R1 equals X. Okay, so if R1 is equal to X, which other angle is equal to X? R4. Why? Vertically opposite. If R4 is equal to X, which other angle is equal to X? M2. Why? Tan theorem. If M2 is equal to X, which other angle is equal to X? What other angle is equal to M2? S. Why? Exterior angle. So easy. Is that not? Remember, we have proven this is a cyclic chord. Can you see that, people? So once you have proven it's a cyclic chord, in your next calculation it is a cyclic chord. Also, if you did not manage to get out A in the exam or in your homework, and you go on to B, you use all properties of cyclic chords there in your. You guys understand? Because remember, most of the time the next calculation is dependent on your previous. Okay, you guys understand? So even if you didn't manage to prove A, you use the fact that it is a cyclic chord in your next calculation. Okay? Alright, so let's just lay this out properly. We write it out nicely. We said let R1 be X, so we said in R4 is equal to XY, vertically opposite. People, in geometry is not only about the answer. Okay? Not only about the answer. It's about your argument, how you laying out your reason. And the links. How you laying out your answer and the links between the angles. Okay? And it's nice, man. Right? And then if R4 is X, what else is X? Angle M2. Why? Tan chord. Okay. And if M2 is equal to X, we say S is equal to X. Angle S is equal to XY. Exterior angle of cyclic chord. Then I can conclude, therefore, angle R1 is equal to angle S, which is equal to X. Okay. Did you guys understand? Something like this is worth 3 marks in the first question, and 1, 2, 3, say about 3 or 4 marks in the second question. Okay. So it's like 3 marks, people. It's only if you want it, no? And most of you don't want it. So you leave it out. Okay. One more. Example 3. And example 3 is on page 318. Am I moving too slow? Huh? I move slower. Okay. Example 3. Come people. Also now what am I doing? I'm reading systematically through the introduction and marking on the diagram. Familiarizing myself with what is given. Okay. At the same time you can already see the type of questions that is coming. Okay, as we did in the previous one. We are told that A, B and C, D are 2 parallel chords. People, if A, B and C, D is parallel, what do we know? Alternate angles. So which angles are equal? C3 and B3. And many other angles we can talk about. We can say that angle A and the sum of C3 and C4 is equal to 180. Sum of triangle cointerior. We can say many things. We can say that angle is also equal to that angle corresponding. Can you see that F there? You can say all of those things. Okay. But what we do is we don't overpopulate the diagram as well. Alternate angles is enough for us already. Okay. Can you see that? But also those things are also equal. Okay. Then we are told that AC and BD both produce. What does produce mean? Extending. Both produce to intersect at P. Where's P here? So we got BD and AC both intersecting there. What does intersect mean? Crossing or cutting. Okay. The tangent to the circle at B and C. So these are tangents. So before I go anywhere else, what do we know? B1 is equal to B1 C3. Why? Did you? Whoops. I'll just show you. I will highlight it to you. For those of you saying, huh? Right. You see there's a triangle? And then my tangent. Can you see that? So, B1 is equal to C3. Can you see here? You get the same marking. Why? Because that is marked 1 dot. So I don't need that arc there. Let's then go back. So C, that, and that is equal. We also know that this angle here is equal to angle A. Why? Is there a triangle here? And a tangent. So what is it? Tan chord theorem. Can you see that, people? Many things you can say at that point. Okay? But we just say a little bit so that it reminds us that it is a tangent. Okay, what else? Then we are also told that QC is also a tangent. So what can we say here? C5 is equal to B3. Why? Tan chord theorem. C5 is also equal to which angle? C1. Why? Vertically opposite. Can you see that, people? And it's equal to C3 is. But also there are 2 tangents, BQ and QC's tangents. So what else can we say? If BQ is a tangent and CQ is a tangent. Yes, what do you say? Tangents from? Common point. So what does that mean? That BQ is equal to CQ. You can't help but love these questions. The bow tie. She's talking about the bow tie. Which? B1? So you're saying B1 is equal to that? So you are seeing a bow tie here. So what does that mean? Without looking at the questions. This is actually what? A cyclic quad. Without reading the questions, we have already proven that's a cyclic quad. Wow. You saying? Yes, you're getting it. Not clicking yet. Listen, it won't click if you haven't done the previous 6 exercises. And if you have done it, start again from 9.1 and go all the way to this here. Okay. You are not going to discover these things here if you haven't done the previous chapter exercises. Then you're wasting your time. Okay. So if you're one of those girls, then you go back 9.1 to all the odd numbers until 9.6. Then you go back, you do all the even numbers from 9.1 to 9.6. Then you start tackling this. Because this is the last question in geometry. Okay? And it's normally like 10 marks, 10, 12 marks. But hang on, the other part of geometry is 25 marks, which is 9.1 to 9.6. You understand? So it makes sense to master that first, and then it will link into this here. Yes. Yeah. Okay. So do or die, get it right this time. Okay, people listen? Okay, listen, we're now going over the topic here. Right? People say BQ is equal to QC. And what can we? Did I talk about the angles that's equal? So that angle is equal to that angle there. Not so? Why? Angles opposite, equal sides. Okay, then we tell that intersect at Q. Alright? B and C are joined, which is a straight line. Prove that C1 is equal to B3. Now we go C1. But we already got that. No? So now you get upset, like, why did I ask this? They don't even let us think. No? Right, so where do we start, people? We start by saying, let, there you go, yeah? Let C1 equal X. People, you don't have to bring your X into everything. Okay? But we must proud about X's, not so? She's saying yes. You shouldn't be. People, so let's see 1 equal to X. Now what? Which other angles equal to? Definitely we won't go straight into B3. Okay. C5 is equal to X. Why? C5 is equal to X. Why? Vertically opposite. Okay. So which other angle is equal to C5? B3. So B3 is equal to XY tan chord theorem. Okay. So therefore C1 is equal to B3, which is equal to, so the job is done. Okay. You get up to 4 marks per sum. Okay. One statement, one reason. Okay. Can I go? Now it's saying prove that B3 is equal to B1. But hang on, what did we speak about B3? So what is B3? X. So if you can prove that B1 is X, you've done the job. Why? Because B3 is X. Okay. So let's go with that quickly. B. So we know that B1 is the same as C3. Can you see that? Tan chord theorem. But C3 is equal to XY. C3 is equal to X. For those of you who can't see it, there we go. Okay. C3 is equal to X. Alternate X. People, you guys can do this. Mustn't be like that with yourselves. I see you guys are making less TikToks now, no? Am I right? My observation correct? Yes? Okay? C3 is equal to x. So if C3 is equal to x, what's the other angle is equal to x? B1 is equal to x. Why? Tan co-theorem. So didn't we now answer the question? Therefore, we state the answer to the question. B1 is equal to B3, which is equal to? Easy. Easy does it. No? Here we are getting to Jamie's question. What's your name, Jamie, no? Did I get it right? I'm proud of myself. You asked to prove that BC PQ is a cyclic chord. People, there's three ways of proving cyclic chords. What are the ways? Opposite angles are supplementary. Exterior angle is equal to interior opposite, or the converse of the bow tie, which we're going to do here. But now, we already know that that angle is equal to that. So where do I start off? I say, since, state the obvious, since B1 is equal to C1, which is equal to x. Therefore, BQPC is a cyclic chord. Why? Converse, yes, of angles in same segment. Or, I was hoping somebody would have said, equal angles, subtends, equal angles subtended by the same chord. That is the proper reasoning. But if you know, if you're comfortable in saying converse of angles in same segment, you're going to get a full mark in you. You see, we are nice people. We just want to give you the maximum mark possible. But you guys are different. You don't want all the marks. But you guys can do this. People, any confusion here? Right. So that basically brings us to the end of the examples for exercise 9.7. So we'll spend a couple of days on 9.7 and then we will do the last part. Okay. So your homework is going to be exercise 9.7, the odd numbers. Okay. Yes.